Hey everyone, solving Advent of Code 2025, day 6 today. I had something in the morning, so I started a bit later, but we'll see what we do now. Cool, so I'm seeing some of this input. Let me just paste it first. List of problems has a group of numbers that need to either be added or multiplied together. So presented next to each other in a very long horizontal list. Okay. I see. Okay. Given a grand total of adding together all of the answers to the individual problem. Okay. This seems a bit like a parsing problem, kind of. So what we know is we can actually say that lines is equals to the contents. The operations line is actually the lines of the very last row of the lines. The numbers is actually the lines up until the very last row. So because we're interested in looking at it column wise, so we can say the column numbers is this array. Well, I guess we can just do it as a regular array, but basically for every row in the numbers, right, we want to split by as many white spaces as we can. I think it's S. Python split by as many. Not entirely sure how we would do that. Okay, cool. I think the default behavior of split is to do that. So for every columns in this, and then if the length of the call numbers is not equal to the length of the columns, well, no. So we can get the row pars, row ints. And then what we want to do is for each of these we add to the column. For C and cell in enumerate over the row integers. If the length of the call numbers is not equals to C, we simply append this, and we said that the call numbers of this given C can append the cell and the operations. So for the data wise, this would be a tuple of the list of integers, and then we need a list of strings for the operations. So we can say that the call numbers and the operations is the data, and it prints the operations. Let's give it the type of list of integers. Cool. So part 1 test, and this would be day 6. Okay. Let's just print the call numbers. Oh no, sorry, not less than. If it's if it's less than or equals to, because there could be times where it is not valid. Yeah, so you can see here in this instance we have 1, 2, 3, 45, and 6. You have 3, 28, 64, 98. Okay. And then basically we want to zip the two for the call and the operation in the zip of the call numbers and the data. If the operation, I think it's either add or division. So if the operation is a plus, accumulation equals to 0 for, no, sorry, we can just say the accumulation equals to the sum of the call. Otherwise, accumulation equals to 1 for C in the call, accumulation multiplied by C. And then answer equals to 0. Can plus equals to the accumulator. You can return the answer. And this should be operations. Oh, I forgot that the font may be a bit too small. Cool. Okay, this is a bit wrong. So maybe let me go and check why this is wrong. 33210. For some reason this is printing out wrongly, so maybe let me just print out the column and see why this is wrong. So the operation is this is strange. Okay, so the operation we should have called split here as well. Yeah, cool. So you see that the answer is correct. So we can actually just copy over this input, which is gigantic apparently, and perform the operation. Oh, it returns 0. Oops, that is a wrong file to update. txt. Oops, why is it not changing tabs? Cool. Okay, cool. So this should be the answer. Yep. Alright. So the math is actually right to left column. Each number is given in its own column, with the most significant digit at the top and the least significant digit at the bottom. So the rightmost problem is actually 4 plus 431. So 4 plus 431 plus 623. So we're kind of going through the digits in this given column. So I think it's a slightly different way of parsing the data, which I think is not a problem for us. So let me just delete everything so that's clean. So yeah, so essentially what we want to do is we could try to convert everything into strings, and we would write pad as the zeros or the numbers as much as possible, and then we just take the column-wise values. So what I mean by this is something like, okay, because there is additional parsing we need to do, let me just create some space first. So basically, for every column in the column numbers, right, let's say the S column is equals to for C in the column string of the C, right? Max length is the max of the S column. I think there is a key. Yeah, there is a key. Is the length operation. Okay, let me just print out what this might look like. Yeah. So we just want to return the length of this. So yeah, so you see that the max is 3. So we say the S column padded is basically for every S column in S column. What we want to do is we want to say rjust, and the width is the max length, and we pad it with zeros. So we should be able to see S column padded. Yeah, so you can kind of see here that in this, for the very first row, it's 1, 2, 3, 0, 45, 0, 0, 6. There is a problem because we are actually literally going downwards. So I guess the justification of the numbers actually do matter to us. Okay, So maybe let's not pad it. Let's just print out the S column and see what we can do with these. Yeah, I suppose it's difficult now because these numbers are all now we can't just strip it down specifically. We do actually need a specific point in which we split it by. Okay. Let me think of a better way of solving this. Okay, what if, let me just experiment with something. 328, 51, 64. Yeah, so you can kind of see here that these numbers are a bit wonky, so we don't actually preserve any additional space, which is kind of a problem for us. Sorry, I'm just checking something. Okay. So yeah, so it does sort of matter where the digits are actually positioned. I guess one of the notes we can make is that for the very last column, or for the very last row, the position of these operations indicate the start of the start of where the first column goes. So I'm wondering if we could do something along that line, where we literally just do that. So maybe let me try to do that. So for now, I have a function that just says if it is test mode. Oops, what is it? Is test mode. Oh no, sorry. If the parts, I cannot remember what was the function for that. If the is test mode. Okay, I don't pass what? Dear. Okay, never mind. It's fine. Cool. Okay. So maybe for now, just for the sake of simplicity, let's just do this. So we can just return the raw contents because each of these perform the operation separately. So I would just want to parse it differently. Cool. So I guess we can do something similar where we say this, right? But instead of doing a split immediately, what we want is to say the column starts is an array of these operations, and for character in the operations, if the character is a blank space, we can continue. Otherwise, the column starts, let's enumerate over this. So we have I. We can append the ith character. And the reason why I want to do this is so that we know the positions of which these operations start, so we know the columns of when they start. and then we will basically have to iterate through these blocks and fill in the gaps of where possible. So actually, one simple thing we can actually do is we could actually say that for each row in the numbers, we can basically replace all the empty spaces with a 0 first. So padded row. Yeah, and then based off of this, we can kind of use my column starts to create the chunks of these strings. So essentially what we want to say is for the start in the call starts, so we can say that these are the cells, right? We want to append the padded row from a given start to the so I guess what we can say is we can enumerate over this. We can say I till the so if the I is less than the length of the column starts, we can simply append to the column starts of I plus 1, and then that's 1. Otherwise, right? And so what we want is to now just check to make sure that the cells are correct. Yeah. Cool. Yeah, so you can kind of see here, it goes 1, 2, 3. So this is not particularly accurate, so I need to do a -1 on this. Yeah, so you can kind of see here now, it takes into account the padding on both the left and on the right. And because now we have taken into account the padding, we can now essentially get them column-wise. So I think there is a pretty smart matrix operation we can do, where we can say the columns is equals to this. We can append the cells, and the transposed columns is, I think, the zip of the zip of the columns. I can't remember if this is the nice algorithm for it. But essentially, yeah, we transpose so that now we have the rows and the columns. So now we have the individual columns. So now that we have the proper individual columns, we can now perform the appropriate kind of operation we want to do. So for the column and operation in the zip of the columns and the operations, right? And so now we can actually split by everything. Let's just print the call and the operation, just to be sure. This should be the transposed columns. Cool. Then now we can kind of line up all of these columns together, or all of the numbers within the column, and process them literally column-wise. So we kind of need to do another transposition, where we would say that the L column is the list form of this column, and the transposed L column is equals to the list zip of the L column. Yeah, so you can kind of see here now that we have managed to pair the numbers accordingly. So the very first column was 100, then it was 240, then it was 356. So with this now transposed column, we can say for number in the transposed columns, we would simply say, well, we can collect the numbers into a nums. So we can say raw num. We can say nums append join of the raw num. We can int this format. And we can print out the nums. Cool, yeah, so now we have the raw numbers that we can use. And these all already account for any trailing zeros or any leading zeros. And then we can do the same thing that we did before, which is basically we can declare the answer, and we can just do this where we can say if we can say for nums, all the nums, and then we can return this answer. Cool. So this is a bit inaccurate. Let's try to figure out why. Okay. Print the operation. So the very last row. I see. I see. Yeah, because the trailing zeros should also not be included. Yeah. So both leading and trailing zeros should not be included. Yeah. Yeah. Okay. So since the trailing zeros should not be included, I wonder if strip trim okay, let's just say the num string is this. Let's strip the zeros along the ends. And let's see what this number becomes. Yeah, so now it's more accurate. It's 124, 356, 8, 248, 8, 175, 581, 32, 623, 431, and 4. And we get the correct answer. Cool. So this is the new answer we've come up with. Perfect. Yeah, I think today was pretty straightforward actually. Basically, this was a very big parsing problem that we had to deal with, where maybe let me clean up code a bit, where in the first part we kind of don't care about the positions. We sort of only just care about whether or not what the numbers were in the column, so we can kind of just brute force parse it. The second version requires a bit more care, so because we need to know how long each string is, so that we know know where in the string each of these like column numbers become. So whether or not it's supposed to be an 8 or a 32 with like a trailing 0 at the very top. I guess we didn't really need to do this. I guess within the operation we could have just went through each of the columns and just manually extract all of the digits. But I think this was a slightly more intuitive way, where what we do is we first replace all of the additional spaces of my number section with a 0, so that we by default pad all of the numbers with a 0. We use the operation starting positions as when we start a particular range, and we basically extract those columns in this way. And once you've extracted all of these columns, we kind of want to flip them again. So that's what the transposition does. We try to transpose them. And once we've sort of transposed them, we then extract the raw number that comes with it and then perform the operation we need. I guess we could just generify this where we could say something like perform operations, call numbers, which is the list of integers, and you have the operations, which is the list of strings, and then you can return an int, and you could, in theory, sort of perform this where we can say call numbers and we can say operations. We can say answer is this. We don't care about this, and we only care about, yeah, and we can just say call. So yeah, so in this instance here, we could say we want to return the perform operations of the call numbers and the operations. And in this instance here, we want to say that the call numbers is this. Yeah, and then, yeah, so in this case, we don't actually really care about, I'm just trying to generify the function a bit more so that I don't have so much duplicates happening. So we can say self perform operations, we get the call numbers, we get the operations split, and we don't need that anymore. Cool, yeah. So I think that is pretty much it for today. Pretty straightforward logic-wise. I think parsing the string was just the tad bit annoying bit. But yeah, thank you guys so much for watching.